Okay, so now we are getting more and more confident with using pandas, how to create a data frame, a series, how we can read and write from cells, segments, and arbitrarily even. And now let's move on to four more important actions in pandas data frame and series. Now we're going to focus a lot more discussion on data frames because by and large that will be how we reflect real life business data in our Python program. So in other words, the the model that exists in our Python applications to mimic the real world tends to be very often data frame. And the reason why series is even there is to support the computation because we may extract, a thin segment of it, a column, a vector, a row out of it, and that correct representation is not a data frame of one row, but rather a series. So we'll discuss series as a sort of accessory. No, by no means disrespectful to series, but it is what it is. And data frame is very crucial. Now, the four things that we want to discuss today in this session is um, the few actions that we find frequent need, and that is to replace, to fill, to append, and to delete rows and columns. So to replace is very simple. Quickly, it is just the data frame, and then you run a dot replace. Okay, replace all the nines. So just by content. So search for all the nines and replace them with 2. Find all the nines in the content. Now, by content, it can be misunderstood as the label content of the columns, column names, and the index labels. So I will use the word label to describe the index labels, the content of the index labels, or the content of the column labels. And I will use the word content to refer to exactly the content, right? So the meat of the table. So replace the content having 9 to 2, and then we will get all the 9s get translated, replaced with 2. But this is where, again, some kind of frustration, bugs, and all that come in. Now, remember that when we discuss function parameter passing, there's this notion of what if we pass structured data? And here we do have a structured data. Okay, so and the point of discussion at that time was basically that when we pass by a non-scalar data values, how is the data value being passed? Is it a copy of the whole big thing or is it by reference? And our conclusion was it was by pass by reference. So it's a pointer to the big value that's still stored at where it was stored. Nothing was duplicated. So same thing here, um, but in kind of a reverse way, is that by default, pandas always duplicates the outcome. Pandas always duplicates the outcome. Now, this is done on purpose. It's a design principle. Why? In the function call case, because function is system-wide, language-wide, there tends to be a lot of cases where we will not want to modify the original caller's big structured data. But if we do, caller can always make a copy first. So it's not so inconvenient to do that kind of default pass by reference. Here, however, pandas is about data and everything about data. And one of the important aspects about data, for example, like security, authentication, and all this, is the integrity of the data, something which pandas can and must preserve. So the integrity of the data, what does that mean? It means that the data shouldn't be easily corrupted, modified unnecessarily. So in this case, for example, when we replace, we are we are not corrupting, but we are intentionally changing the data for good reasons due to the applications. We are changing the data. One of the principles of data processing is that you don't modify nor discard the original data. The source data that's being captured even if it has noise, is important source of information. For example, if your sensor keeps recording a lot of wrong information, other than the necessary fact to delete the incorrect information and process accordingly, the wrong information also tells us, that the sensor is a little bit faulty. We probably need to change it. So if you replace the original source data and sort of make it look good, we would never get the idea that the sensor is having problem. So same thing, one of the basic principles is don't delete data without good reasons, right? Without good authority, and don't corrupt data. So in that sense, by derivation is don't modify the original data. So based on that consideration, we could, or pandas could, either always modify the original data frame. So if we say df3, then df3 itself is always modified, becomes 83222107. But that would mean that subsequently, when we say df3, we thought it is 8399, it becomes 8322, and there's something disastrous can happen. Because we thought, if I didn't modify df3, then df3 shouldn't change, right? So for pandas, it is not about inefficiency or saving memory and all that. The overriding consideration is don't modify data frame values uh, uh, without explicit authorization. That means if I just say replace 9,2, I'm asking pandas, can you modify, can you change it? Pandas can do it in two ways. Do it, then give me a new copy, but doesn't modify df3. But the effects are recorded in df4. So I did get the job done, but I didn't change your original data. Or I do it and I change your original data. If you do that, it might be because original data is 5 GB long. And if you make a copy, it will very much slow down the processing because you're changing a couple of nines to twos. And then you copy a 5 GB data over. Now it's 10 gigabytes, right? So which one? Which one is a better default basic operation principle? So for pandas, the chosen principle is don't modify the data frame unless you explicitly state so. That is clear, right? So if I insist and I put in I insist, no, sorry, you don't say that. You say in place, not insist. Insist equals true is probably true also. So you say in place equals true. That means modify in place. df3 is the place. Change my nines to twos. Do it right here in place equals true. Then that is explicit authorization for pandas to modify yourself. Don't blame me if you get some errors downstream. But most likely because the programmer actively, positively says so, right? Most likely it will reduce any miscommunication. And programmer already expects df3 to be modified. Maybe df3 was already a redundant copy and now it's ready to be replaced anyways. Something like that. So with explicit positive indication, then pandas modifies in place. So keep this in mind. In mind equals true, please, right? So keep this in mind, in your mind, because we'll see a lot of these in place equals to true to be used all through. All right, so the default is if you didn't have the in place equals to true, the in place is equal to false, which means pandas will do the thing and return you a new copy, and we put it in df4. And if you don't put it in df4, it will be gone, and df3 wouldn't be changed. And don't be surprised that, hey, how come nothing was done? All right, so that's the idea. So this is very important. I want to just emphasize it a bit. Okay.